In this example, we have a polynomial of degree 5 and we want to use ad hoc calculations to prove that this polynomial is big omega of its dominant term, which is x raised to power 5. Remember that for polynomials with some negative coefficients, finding big omega of this polynomial is not straightforward. So we need to find a trick to prove that this polynomial is greater than or equal to a constant multiplied by the dominant term, which is x raised to power 5. Before we proceed, we would like to write down first the dominant term, which is x raised to power 5. And also we need to write down the next dominant term, which you are going to call it subdominant term, which is x raised to power 4. Also, for any positive number x greater than 1, if we have two rational numbers a and b such that a is less than b, then the power functions for a and b, x raised to power a is less than or equal to x raised to power b. When we multiply both sides of this inequality by negative number, the inequality sign will change, will be in reverse. So when we multiply both sides by a negative number, we will have minus x raised to power a, but instead of less than or equal to, it will be greater than or equal to minus x raised to power b. As an example, for example, if we have a equal to 2 and b is equal to 7, then the power functions for x raised to power 2 and x raised to power 7, since 2 is smaller than 7, so we have less than or equal to. And when you multiply both sides by negative number, minus x raised to power 2 and minus x raised to power 7. And since both are negative, so we pick the power with the smaller number and we will write it as greater than or equal to. Similar to what we have done previously on a similar example, first we will split the dominant term. We'll split the dominant term x raised to power 5 into two parts. We have the coefficient for the dominant term is 1. So notice here that the dominant term has the coefficient 1. So we will break this dominant term into two parts, into two halves. So half x raised to power 5 plus half x raised to power 5. At the same time, we are going to remove all terms with positive coefficients. And what are these terms in our example? In our example, these terms are, this is 1 and this is another one. After removing the positive terms, then the resulted polynomial, so we will say that f of x will be greater than half x raised to power 5 plus half x raised to power 5. Let us see what are the remaining terms, the negative ones, minus 3x raised to power 3 minus 2x squared minus 3. So we started from the beginning with our original polynomial. We splitted the dominant term into two halves and we removed all positive we remove all terms with positive coefficients, and this is the resulted polynomial, and it is smaller than the original polynomial because we have removed the positive terms. Next, for minus 3x raised to power 3, we know it is greater than or equal to minus 3 x raised to power 4, which is subdominant. And also minus 2x squared is greater than or equal to minus 2x raised to power 4. At the same time, we have minus 3 is greater than or equal to minus 3x raised to power 4. So what are we doing in this step? We are leaving the dominant term, but every other non-dominant term, we replace it by the subdominant term. Remember that from here, if we have two power functions and both are negative, and then the one with the smaller power will be larger than with the one that has larger power. So here we have x squared, both are negative, so this term is, or this power function is greater than or equal to this power function. We will do this replacement, okay, over this polynomial. So we will have greater than or equal to half x raised to power 5 plus half x raised to power 5 minus 3x raised to power 4 minus 2x raised to power 4 minus 3x raised to power 4. And again, if you look at this polynomial, these two are unchanged, but every other non-dominant term has been replaced by the dominant term. And in fact, this polynomial should be greater than this polynomial because we replaced every non-dominant term by the subdominant term. Now combine these terms together. So this will be equal to half x raised to power 5 plus half x raised to power 5 minus, add the coefficients, 3 minus 2. So minus 3 minus 2 minus 3, it will be equal to minus 8 x raised to power 4. When you look at the last polynomial, if you prove that this is positive, so let us write it down. If half x raised to power 5 minus 8x raised to power 4, if we can prove that it is greater than or equal to 0, let me circle it. So I will just circle it. If you can prove that this is greater than or equal to 0. So you have one number plus another positive number, then definitely this equation, which is half x raised to power 5 plus half x raised to power 5 minus 8 x raised to power 4, greater than or equal to only this part, which is half x raised to power 5. So let us look again into this polynomial. Now this part is exactly the same as this part, but if we can prove that this is positive, so any positive number you add it to half x raised to power 5 definitely will be greater than or equal to half x raised to power 5. And here we will assume now this is the value of c. So to find the value of k, then we need to solve this inequality. So let us solve this inequality. For half x raised to power 5 minus 8x raised to power 4 greater than 0, then we will multiply by 2 and take x raised to power 4 common. So we will have x raised to power 4, x minus 16 greater than or equal to 0. From here, by solving this inequality, then either x less than or equal to 0 or x greater than or equal to 16. But x is less than or equal to 0 is not accepted because the value of x is supposed to be positive. So in this case, we can consider that k is equal to 16. So therefore, here we can say that f of x is greater than or equal to 1 over 2 x raised to power 5. And if we consider the value of c is equal to half and k is equal to 1 as witnesses, then we can say that f of x belongs to big omega of x raised to power 5.